In a world where global populations are surging and the electrical grid is expanding, the demand for electricity is skyrocketing. But with climate change looming, the search for renewable energy has become urgent. Among these alternatives, wind power shines as a cost-effective and boundless resource. This brings us to the world's largest wind turbine, a groundbreaking solution for our energy needs. But what challenges does it overcome? How does it harness the power of the wind? Join us as we explore the revolution of renewable energy and the quest for a greener future. The world's most urgent task is the development of renewable energy, especially in rapidly developing countries like China. In 2009, China began developing offshore wind power near Shanghai. And just a year later, Asia's largest offshore wind farm was completed, situated beside the East China Sea Bridge, in time for the 2010 Shanghai World Expo. During that summer, Chinese engineers drew up plans for the world's largest offshore wind turbine, the SL5000, on the other side of the bridge. The top of the mechanism cabin is as large as a helicopter pad, and the rotor alone has a span of 128 meters, presenting unprecedented challenges for the engineers and workers. The parts of the SL5000 were manufactured in different places and assembled at Yangshan Port. The cargo ship carrying the landing deck and the semi-submersible vessel for offshore installation arrived at the onshore assembly base on August 5, 2011. However, according to the weather report, Typhoon Plum, the 9th typhoon of 2011, is headed for Yangshan Port. Workers need to transfer the machinery cabin to a safer place, and the semi-submersible ship needs to enter the harbor. To ensure the safety of the huge SL5000, an extra-large semi-submersible ship will be used, requiring the pier to be enlarged 2 months prior to accommodate its width. As the weather worsens, Jung checks the wind direction and starts the engine to lift the 300-ton machinery cabin onto the tracks. While it's not a difficult job for him, he worries about how the wind will affect the rest of the operation. Various departments worked together for 6 months in early 2011 to draw up the blueprint for the world's largest wind turbine, the SL5000. Soon after, several leaders in the wind energy industry signed a contract to produce it. On August 2, 2011, China's largest offshore double-boom crane ship, the Fengfun, arrived at the deepwater port of Hangzhou Bay on Yangshan Island, 38 nautical miles away. China's largest crawler crane and its skipper, Jung, prepared to assist the Fengfun with an unprecedented assembly task. This crane, worth as much as a Boeing 737, boasts a 9,000 horsepower engine and can lift the weight of 800 passenger cars to a height of 40 stories. The two vessels will be installing the world's largest wind turbine, the SL5000. Rough seas and unpredictable weather make this project a huge challenge. As oil and coal consumption has been increasing since the Industrial Revolution, non-renewable resources could be depleted soon, causing concern worldwide. The turbine blades of this foreign wind turbine are as tall as a 40-story building, and helicopters can take off and land from the top of the machinery cabin. It doesn't use fuel or cause pollution. In fact, it can generate 400 million kilowatt-hours of electricity over a 20-year design life. This turbine is a giant among wind turbines. Assembling it in choppy seas during typhoon season posed an unprecedented challenge. The first step in constructing the SL5000 is building the main frame, which must be robust enough to bear the force of the wind and the weight of the turbine and mechanism. To achieve this, a powerful cutter is used to make parts from thick steel plates. This cutter can accurately cut out any computer-designed shape, ensuring precision in the manufacturing process. The main frame of the SL5000 must withstand the enormous torque produced by the world's longest turbine blades. Any weak spots in the welds can reduce the frame's strength, leading to catastrophic consequences. To prevent this, workers use an ultrasonic tester adjusted to maximum sensitivity to ensure the quality of the welds. Foreign inspectors are also involved to ensure that the wind turbine can withstand the harsh natural conditions it will face. Building the main frame is just the first step, and the next stages promise to be even more challenging. The turbine blades required for the SL5000 will be unprecedented in size, making their production extremely challenging. China's largest blade manufacturer has accepted the challenge. Blades of any size or shape must be both strong and light, which are conflicting characteristics. The blades will be offshore and subject to erosion and severe weather, which will severely test their durability. If the blades are not strong enough, the result would be disastrous. The blades on the SL5000 will be the world's longest and largest, meaning they will also be subject to a great amount of torque. Proper selection of materials is critical. Tests settled on epoxy, a material with excellent chemical and physical stability. However, epoxy is brittle, so fabric was embedded in the epoxy resin to make a composite material known as FRP. It was hoped that the fabric would make the epoxy suitable, reducing the thickness and weight of the FRP to 1/4 of the original epoxy, increasing the strength more than tenfold. FRP, therefore, appears to be the best choice for the blades of the SL5000. To make the blades as aerodynamic as possible, they must have a specific shape, but this also makes it even more difficult to produce them. A prototype must be built first and tested to confirm that the blades can meet design requirements. 6 months later, the prototype is ready to test. Installing the SL5000 presents several significant challenges. One of the foremost challenges is the sheer scale of the turbine. The SL5000 boasts unprecedented dimensions, with turbine blades as long as a football field and a mechanism cabin towering as tall as a 40-story building. Such colossal components require specialized equipment and expertise for transportation, assembly, and installation. Transporting these massive components to the installation site poses logistical challenges. Once on site, the assembly of the SL5000 presents another set of challenges. Given the turbine size, assembling it in choppy seas during typhoon seasons requires skilled labor and advanced engineering techniques to ensure safety and accuracy. Any errors during assembly could lead to delays and costly setbacks. Additionally, the SL5000's installation must consider environmental factors and local regulations. Coastal areas, where wind resources are abundant, are often ecologically sensitive zones. Balancing the need for clean energy with environmental conservation requires careful environmental impact assessments and mitigation measures to minimize disruption to marine ecosystems and wildlife habitats. Weather conditions also pose a significant challenge during installation. Offshore wind farms are particularly susceptible to adverse weather, including high winds, rough seas, and storms. These conditions not only endanger the safety of workers, but also hinder construction progress, leading to project delays and increased costs. Well, that's about it for today's video. What are your thoughts about the SL5000? Let us know in the comments below. We would love to hear from you. If you liked today's content, do give us a like and subscribe to the channel. Thank you so much for watching, and we'll see you on the next one.